In this video, we're going to start a new Unity project, load in our piping models, make sure that they're accurate and everything is as we expect it to be, and then of course, try playing with them by connecting them using snapping settings. Go ahead and go to New. I'm going to use 2019.4.x. I'm going to go to a 3D project, and let's just call this Pipe Test. Choose a convenient location. For right now, since this is a throwaway project for me, it'll just be the desktop. Hit Create. While the project gets ready, I'm going to go ahead and open up two folders. First, I'm going to open up my textures folder, and I'm also going to come over here and find my models folder. So coming over here, take a few seconds and lay out your project however you see fit. I'm going to come over to Project, right click, and we can do Import New Asset, navigate to the proper folder, and then choose one of the low poly versions of your model. First, we'll start with pipe2.fbx. The asset that you import into Unity is not the same asset that you end up seeing in your scene view. The process of importing assets means Unity has to read the file, adjust it, delete, or add different items based upon whatever functionality it finds or you decide to set up. Now, if we open up pipe_2, you'll notice we have a no name material. That's on me. I should make a note to whoever was doing the 3D modeling that please properly name your materials. Next up, we have the actual mesh name, which is just pipe_2. When you select the overall object, you'll notice that in your inspector, you get something very different. We don't have a view of the components or the transform or any of that interesting stuff. Instead, we're actually bringing in the import settings for this 3D model. Here at the top, you'll notice that there's a scale factor. Many times when you're bringing in assets from various programs like Maya, Max, or others, this scale factor can be very off. And that just depends upon the units you use to model it and the units you use to export it. The fastest way to check if this is correct is to grab your asset and just throw it in your scene. I usually also like to go to Game Object, 3D Object, and open a cube up. I hit F and I compare the size. The cube should be 1 by 1 by 1 meter. Here's my pipe and you can see what it looks like there. Now we do have some strangeness going on with the surface, and that's due to the fact that we smoothed the entire object. I smoothed the entire object because the hard edges of the surface were actually causing problems when I was trying to use Substance Painter. This will disappear once we bring in our textures, so don't worry about that yet. What you really need to be concerned with right now is whether or not the model looks correct. In addition, many times the lighting in the scene can really make it difficult when you're new to determine whether or not there's something wrong. So go ahead up to the top on your scene view and click this little bulb to get rid of it. I'm also going to get rid of the game view for now because we don't care about that as much yet. Here we can move around and we can see what's going on. And I'm not seeing any missing segments or sides, and the scale looks fine, so I don't need to make any changes there. However, if we come to Pipe 2, what you'll notice is my scale automatically gets set to 100, 100, 100. My personal workflow is to be as clean as possible at all times. You'll notice that my rotation is set to a -89.98. My scale is set to 100, 100, 100. I don't want to have to remember or store in a script these values if I ever try to manipulate the rotation or the scale in order to get them set up properly. So this is a time when it might be a good idea to go back into Blender and reorient my object so it works appropriately. Or we can try to do things inside of Unity if that's not an option for you. One portion here is this convert units 1 centimeter scale to 0.01 meters. When I was modeling in Blender, I wasn't working on a 1 centimeter scale. I was working on a 1 meter scale. So I'm going to deselect this option and hit apply. What you'll notice is the object gets enormous. The reason for this is because if we select Pipe 2, we still have that 100, 100, 100 deal over here. We just jumped from centimeters to meters. So let's make a change here and try 10 by 10 by 10 and see what we get. There we are, still too large. So once again, let's go down by another factor of 10, and that's more like it. What's important here is that we get a one-to-one relationship between what we export and what we expect. This minimizes the amount of work someone has to do when they come into our program and try to manipulate our objects or import them in. It's always a good idea to report these sorts of mistakes to the other members of your team so that you don't have to be the one cleaning up their junk. Now there's other settings here that are kind of important that you might want to check out. There's things like import visibility, cameras, or lights, and most of the time you won't want any of these options on, but since we were smart and did a selection and then exported those objects, there weren't any cameras or lights in the scene anyway. There are also some options here that may potentially change the layout of your object. So if you needed an object to have a certain vertex order and a certain number of quads or polys, you may want to deactivate or activate certain settings you see here. In addition, here it says import normals, but you could have it calculate normals on its own. Also, you'll come down further. Also, if you come down further, you'll see there's a generate light map UVs. This is a second set of UVs that can be auto-calculated by Unity if your object doesn't have a second set of UVs. You could use the existing UVs if they're unique and just duplicate them to another UV set if you wanted to, or we can select Generate Light Map UVs, and you can mess with the different parameters here to determine how it unwraps your object. If you try to bake the lighting in your scene, Unity will usually give you a warning about which objects do not have unique UVs. And to go into this menu and go ahead and turn on Generate Light Map UVs yourself, or go back to your 3D modeling application, create your second UV set, and make everything there. Now here we notice my object is facing down the Z-axis, and it's also down the world Z-axis. However, I've got this annoying rotation factor of 90 degrees. Now for a pipe, orientation doesn't matter as much, but if you're bringing a different object, like a character or something that clearly had a forward-facing direction or an up-facing direction, you really do want to get this aligned properly so you don't need to deal with manipulating these transforms or having any kinds of offsets. One quick trick is just to go to Game Object, create empty, and call this something like pipe_2_G for group or game object, it's up to you. Then click and drag the other object under it. Hold down the Control key and snap this to whatever angle you'd like. And now you have an object within an object, so a transform buried underneath another one. Now you do need to be careful. You'll notice here that the pivot on this object is way up here in the sky, so you're probably going to want to reset your transforms, then go back to your original object, and then reset the directions over here. This is one way to get around the issue, but just realize you've just nested an object within another object, and if this becomes commonplace, you're really kind of bloating your scene. What I like to do, usually for static objects where I know I don't have animations or any weirdness that might be going on, or if I can export this out cleanly, we'll jump back to Blender. I'll take a look at that pipe object really fast, look at my transforms, see that they're all zeroed out, see that my scales are all 1, that looks fine. I'll come over here to my export settings. I'll check selected objects only so I don't get everything else in the scene. You can turn off other objects if you want to, but you're going to want mesh on, that's for sure. Come down here, scale looks fine, this looks fine, this is fine, Y should be up. I'm going to hit apply transform. Now in a prior video I did, I actually turned this setting off because I was getting improper scaling of different objects when I brought them to Unity. You'll notice that it's got a big warning sign, and if you mouse over it, it even says this is a known issue with this feature. It will break some things, especially armatures or animations, basically rigs of characters or other systems and setups. Under geometry, normals is what I want. Applying modifiers is fine. I believe I still have that triangulation modifier right here on the object. And then of course, calculating the tangent and binormal vectors is necessary in order for us to make sure our normal map looks proper. I'm going to turn off bake animation because there is none. We'll get a big red warning down here because we already have an asset with the same name. I'm going to hit export anyway, and we're going to come back into Unity. I'm going to come over here and just delete the asset. Now this is truly deleting the asset. It's gone now from that folder. Go ahead and open up the folder where that asset lives, and let's find pipes 2 and drag and drop that into our project folder. So here's our pipe again. Select that object, make the changes we just saw, convert the units properly. Come over here, let's delete out that pipe and put in another one. There we are. And here we can see what's going on. So we have this huge scale of this object. We come over here, we'll see that our scale factor is 1. Our converting of our units was turned off. However, our object still remains huge. So this is once again an issue with that whole transform. What we will notice though is that our rotation is fine. We no longer have a 90-0-0 issue going on here. Easiest way to fix this is just by adjusting your scale factor. Let's try converting convert units back on for a second and taking a look at our object. What we'll notice now is, with that convert units selected properly and having exported this object out using that experimental mode, not only are our rotations correct, but our scale is now correct. Now I did one other bad thing, and that is I went all the way back to Blender, but I didn't bother changing the name of the material. So why don't we go back to Blender here, check my pipe 2 out, come down here to the material section, and you'll notice that we have several different materials here, but nothing for this pipe. So let's go ahead and create a new one, and we'll call this pipe_2_M. Let's try this export again. File, export, FBX. All our settings should be set up and remembered. I'm going to hit export now. Come back into Unity. Once again, delete that asset out. You'll notice that this one disappears. Right click. We'll go ahead and import a new asset. And we'll do pipe 2. And here it's back again, checking our settings, 1 centimeter, that looks fine. Check our world, 90 degrees, no issues, that's all fine as well. You'll notice we have a material with the proper name. The reason why setting up your names is important is because many times you'll have multiple assets, potentially with multiple materials. And having them with default bad names is going to make your life really nasty in a second. Because we're going to go over to the Materials tab now, and I'm going to extract the materials from this object. You don't have to do this. You could manually create the materials inside of Unity, but extracting them means you get the proper name there and the proper number of materials without any real work. I'm going to create a new folder here, and really I should probably be calling this just pipes, something similar to that. Within this folder, we can then break it down in 2 ways. You can do it per asset, or you can have all pipes in here and then one folder with materials. It really depends upon your preferred workflow. Just going to create a materials folder in here and select this folder and export those materials out. Now that we've done that, we can jump over into our textures folder, which is right here. I can find pipe 2 and I can find the different variations of that pipe. I'm going to grab them, I'm going to hit Control C, I'm going to come over to my project, and I'm going to right click and show and explore. This opens up the folder that you're currently looking at in the project, not the one you have selected. So it's going to be the assets level, not pipes. Open pipes, I'm going to right click, create a new folder, and I could create a textures folder here, or if you did it per asset, you could create multiple folders and then combine both the material and the textures in the same place. Really depends on your workflow. Right now I'm just going to paste these in place here. Right click, new, and let's call this, let's delete this one. I'm actually going to go into materials and I'm going to Control X that material and paste it into here. And I'm going to Control C, Control V, Control C, and Control V. Now, if you read a lot of Unity documentation, many times they tell you not to work in the Explorer. However, over the many years that Unity has been out, I find that simple operations like copying and pasting typically are just fine, and Unity has no issue with this sort of thing. We'll go to pipe 2, and we're going to want to change these names to match the ones above. So we want gray waste, and then we also would like to do red hot water, and then finally we will do yellow flammable. And then if you'd like to, you could drag these into each of those individual folders. It's really up to you and your workflow. Just trying to show you different ways of approaching the problem. I'm going to go ahead and delete that materials folder because it doesn't look like I'm going to even use it. We're going to come over here to pipes, and I am going to drag my pipe and my pipe metadata into the pipes folder. Coming back over here, give Unity a second to read all those changes that you made, and you might have some issues. Here you'll notice that it's saying there's a meta file existing, but I can't find the actual asset. So we're just going to get rid of it. If we jump back under pipes, you'll notice that here we have the various different materials already. So why don't we take our pipe 2 object and duplicate it by hitting Control C, Control V, Control C, Control V, and let's name these appropriately. So we have pipe 2 underscore, and we could do red hot water. We could do pipe 2 underscore, and we'll do gray waste. What you need to understand is this part is up to you on workflow. You could have created these various objects with their various materials inside of Blender. However, more often than not, there's usually disconnects between each stage. For instance, the modeler might create a generic asset, but not understand that there's going to be maybe 4 or 5 different texture sets created by the texture artist, if these are different people. And then the person in Unity is going to be getting a model and then a series of different textures. And that person might need to go in and create duplicate materials or other objects to make things work. Here we've got red hot water. I'll move this to the side. We've got green, we have gray waste, and then yellow flammable. So let's connect things properly. I'm going to hit clear on my console. And actually, I don't really need the console taking up so much space. So why don't we just drop that down over here for a moment. In my project folder, let's drag this over onto the side because we don't have a very big hierarchy at the moment. We can come to our materials and we can drag and drop these into the correct slots. We're working with the standard shader right now. The standard shader has different rendering modes based upon if you want to support varying types of transparency. We have opaque, which is no transparency whatsoever. And the important thing to understand is opaque with no transparency means even if you apply transparency to a texture, you will still not see anything. It's not going to process transparency at all, and it will ignore any of your transparent inputs. Next up, we have cutout, which basically means a binary on or off value. That is removing pixels or keeping them. This is a very cheap form of transparency because you're not actually blending anything. Then we have fade. Fading is when you want an object to completely disappear and reappear, almost through teleportation or magic. Whereas transparent, the final option, means it's going to render the object as if it exists, just that visible light passes through it for the most part. Of course, when light strikes a transparent object at a certain angle and the viewer is also at a certain angle, of course, light will bounce off the surface and not penetrate into it. Therefore, transparent objects will still have highlights on the surface even though they're supposed to be fully invisible. If you're going for realism and you're making glass or other objects, go with transparent. If you're trying to make an object disappear like an item after being used, go with fade. And if you're trying to do things like vegetation or other objects like that, you might want to consider cutout for its performance implications. Now all we need to do is we can drag and drop our textures over here. But when you're new to this program, sometimes you'll fumble and you'll click something and then your inspector changes. There's two different ways of handling this scenario. One way is creating a new inspector tab. For instance, we could come down here, click ... add a tab, and add an inspector tab. By default, these inspector tabs are going to show the same thing. So if I move around, you'll see everything changes. However, the lock button at the top means I can lock what it happens to be referencing. So we could, since we're going to be dragging and dropping things, select the material, lock this inspector, but make changes over here to our selection so that we can make changes to the texture file if necessary in its import settings, but still be able to drag and drop these over one at a time. So let's go to albedo trans and put that in albedo. We have ambient occlusion, which we'll put into the occlusion slot. Then we have MS for metallic specular, which we'll put here in this metallic channel. We do want the source to be the metallics alpha channel. That's where it was stored. Then finally we have our normal map, which we can click and drag here. You'll notice that it says this texture is not marked as a normal map. Remember, the data inside of a normal map are the vectors expressing directionality. What most people don't realize is that color textures pass through this sRGB function here, and this causes the values that are stored to be modified. If for some reason an object should not have its values modified, especially if you're using a texture to drive numbers or generation or to store things, you do not want to have sRGB on because what you get is not what you put into that texture. So here, if I select normal, you'll see it's sRGB. If we go to texture type up here and choose that to normal map, you'll notice that that option completely disappears because normal maps are data. They're not visual components necessarily directly. They will be used to drive visualizations, but we need the exact value. I'm going to go ahead and hit apply here. If you want to, take a look at the different textures and get a sense of what's actually going on here. There's a texture type and several different ones. There's that sRGB, which is transferring the data value from one mapping to another. There's alpha is source. Here you get to specify if the texture has alpha. You can specify that it's from the alpha channel, that it has none, or you can specify that it's from the grayscale. If you've never converted an image of color to grayscale before, it's a very simple operation. Usually you multiply each component by a different weight. That is maybe for red, something like 0.3, green 0.5, and then of course blue maybe 0.2. The human eye is mostly sensitive to greens. That's why it gets the heaviest balance. And then the other two, red less, and of course blue is the worst color for most human beings. We have alpha is transparency, but ultimately what it does is it simply signals that when I visualize this texture, the parts that are black or semi-transparent should show up in the preview window as being such. So opacity goes from 0 to 1, where 1 is fully opaque. Next up are our powers of 2. Just take it from me, you want to keep your images as a power of 2 unless you're using GUI elements. In addition, you can determine how bitmaps are generated, which are those smaller various versions of your texture. And if you'd like to, you can even see the different bitmaps that are generated by scrolling this little slider left and right. Next up are three very important portions of this. The first is wrap mode, which is what happens when the object exceeds the 0 to 1 UV area. If you're creating tileable textures for a floor that repeats over and over and over again, you're going to want to have this as repeat. However, if you're dealing with an object that does not extend outside of it, very often you might want to clamp. There's also mirror, which just flip-flops things as it repeats over and over again. And then there's per axis, which allows you to specify the U, V, or W axis separately. We then have filter mode, which is how it filters the texture. So when it samples a value on this object, it's going to be sampling a value that's never pixel perfect. So it's got to use some sort of interpolation technique to determine what value to write to the screen. Finally is the aniso level. This is important, especially if you're looking at your textures from a glancing angle. This is going to increase the number of samples that are performed. Obviously, more samples, more computations. However, if you're noticing your floors or your ceilings or other elements looking a little blurry as they trail off into the distance, consider increasing this to something like 4. The last area here is important if your project is getting too large. We exported our textures out as 4096 size. That's pretty huge. However, inside of Unity, you can specify the default maximum size so that while you might retain the highest quality on your end, if during testing, or if you decide to deploy this to maybe a different device or console, you can always come in here and choose a lower resolution version of your textures. What's important though is, based upon the different platforms that you're targeting, you can also do this per platform. So if I'm going for my PC market, I might crank this up to 4096. However, if I'm releasing this on the Switch, I might consider dropping this down to 1024. Or if I have other constraints, such as making this a web or streamable asset, there are other things I might do to reduce file size. Once you're done, you need to hit apply. If you don't hit apply and click somewhere else, it will ask you to apply these settings, if there are any to be made. So I'm gonna go ahead and hit apply, and then go through the different textures, and if you want to, make sure they're okay. So here, normal map's good. Usually I will crank up the aniso value at least to 2 and hit apply. Now you'll notice those are per texture settings. Unity will give you a warning saying you may want to go in there and adjust the overall value for interpolation in your quality settings. Now we can find our red hot water and then grab our material and move it here, or since we name everything appropriately, it's easy enough to find by just clicking here and then searching for red hot water, and there it is right there. Let's quickly finish up the next 2. We'll go to gray waste. Once again, I will come over here to gray waste, select this one, turn this off, and lock this one again. And we can come down here and take a look at these. We can go to normal map and set that up as normal here, hit apply. We can grab these. We can go ahead and boost up that aniso level slightly, hit apply to all. Then we can drag and drop our textures as necessary. So here we are, albedo, ambient occlusion, MS, and norm. Now, if this whole thing becomes tedious, if you follow a proper naming convention, you can create your own systems for importing and exporting these assets automatically and binding these names properly. Yellow flammable, click, select the material, select unselect to lock, come up here, grab my values, increase them if necessary, change anything if I want to, such as the normal map, and hit apply, and then once again, drag and drop in the correct slots. And we can, of course, just drag and drop these onto the appropriate object, either here in the viewport or here in this area. Since you saw that process already, I'm going to very quickly go through the same process, but for the bent pipe. Right-click, import, or we could drag and drop. Here is pipe bend. Look at the model, drag it into our scene. Pivot looks nice. Should be easy to link up with other objects. Transform looks fine. Taking a look at pipe bend, everything else here looks okay. And just taking a look, we have no strange rotations or scaling. We did name this properly, so we can go to materials. I can come down to extract materials, come out here, and once again, we could either make a textures folder and put these all in. We could create a separate pipe 2 folder and a separate pipes bent folder. Once again, it's up to you. So we'll do pipe underscore bent, bend, go in here. I'll select this version. It will then have exported that out under pipe bend, as you can see here. Now we will go into our textures folder, texture bent. I will grab these 3 here, and I will just paste them into this folder. And actually, I think I do want to break things up a little bit. Pipe underscore 2. I will grab these pipe underscore 2s, these meta files and FBX files as well for this object, and move them under pipe 2. And I'll do the same thing here. Come back over here. Since names didn't change, Unity should be able to understand the changes that were made. Here you can see everything looks fine, and our objects look fine as well. There is a limit to how much I will do outside of Unity Editor, and that's kind of it. So now under pipe bend, we have our different objects and our material. Once again, we can come down into pipe bend, and we can do this inside of Unity if we want to. So hit Control D, duplicate this a few times, come over here and rename it. We can just call this gray, red, and yellow. And we'll notice that my naming convention started to break down a little bit here. And this is where I might want to go back and change some of these names, or officially document, if I'm working in a group, that I've gone through and I've made these changes. Because gray waste, red hot water, yellow flammable, it's getting a bit long. These names are a little bit more concise and are probably going to be better to work with in the long run. So I should go in there and change them as well. Now we have our separate folders. We just need to line everything up. Drag and drop our albedo, ambient occlusion, metallic smoothness, and normal. Hit apply to fix now on that. Select the textures if you want to. And I'm going to increase that Aniso level slightly. I'm going to come to this pipe now and do the same process. Albedo, ambient occlusion, MS, and norm. Another thing that I sometimes do is I'll change the naming of these so that they line up with the names in the inspector on the side. So it's easier to drag and drop if you plan on doing that a lot. Let's just fix these really fast and come down to our last object, fix now. And now we just need to duplicate this object a few times. 1, 2, there we are. And of course, name them. We have pipe bend underscore gray. If you prefer EY, go for it. That's actually how I normally spell it too. Now we can just drag and drop our materials onto the appropriate objects. Now it'd be great to be able to reuse these assets over and over again, correct? So why don't we create a new folder, or within the pipes folder itself, we could create a prefab folder. Once again, simply depends on your preferred workflow. You can either have one large prefab folder, or you can have them situated throughout. Usually as I'm working, when I'm adding new features or new content, I will give them their own folder because it's kind of a working area. And then once something has been determined to work and it's been used throughout, I will then reorganize it back into the overall project hierarchy. This way, new and experimental features are self-contained. And in addition, if I need to share this ongoing work with someone else, I can put it into a package very easily, as opposed to having multiple folders strewn out all over the place. So now under Pipes 2, we're going to come up here and drag and drop our asset. We do this in order to create prefabs. I'm going to create an original prefab for this object. We're going to do this for the gray waste, and we're going to do this for yellow flammable. Notice how the icon now changes. This is a prefab object, which means it's not the model being dragged and dropped into the area. It is a Unity game object. We can attach scripts and all kinds of additional functionality to this object, and it will remember how we set it up, and it can be reused or variants can be created later on. We'll come down to pipe bend, open up prefab, and do the same thing for bend. Once again, we're noticing inconsistencies in my naming convention that we really should go back and fix. For instance, here, this should be pipe bend. With that, we have all of our assets inside of Unity. However, how do we conveniently use these to create a quick layout? The way I would do that is I use my snapping settings. Because we are smart and we spent time putting our origins, our positions, and making sure everything's in the right location, we can come up here to our grids. Specifically, I want to come down to grid axis and hit ... Go to Edit Grid in Snapping. Now, the snapping feature for the grid, or snapping to the world, used to be a package inside of Unity that you had to enable. However, it has been seamlessly integrated into the scene view now in these versions. What's important here is your grid size. Now, the grid is very difficult to see right now because of this gray background. I'm going to come up here, I'm going to click on this drop-down that toggles the skybox, fog, or other various effects. It's really the skybox I want to get rid of for the moment. Now this gets rid of it in the scene view. If you come over to your game view, you're going to see it still exists. If your issue is getting rid of it in the game view, you need to go over to your main camera and choose your clear flag. Here I can choose a solid color instead, and we can make that black if we'd like. Now, as I mentioned, right now there's no snapping going on, so moving and positioning these objects is going to be somewhat awkward. We can, of course, do it up here and put in whole values, but it's much faster to work interactively with the mouse, and if this would naturally go to the right location, we wouldn't have anything to worry about. Now, nothing is ever going to be perfect, and don't ever try to make things exactly perfect. But following these conventions is just going to set you up to make things easier. And then, when you have a really good layout with things on the grid, so to speak, you can then break that convention to add additional details or objects. But fundamentally, 75–85% of your level is properly laid out and easy to manipulate. Okay, so the next question is probably, how do we actually turn the grid on? I'm going to go to Edit, and how do you determine anything? Well, we just go into the settings and we take a look. Here we've gone into Edit, Shortcuts, and brought up this convenient menu that Unity has. And you'll notice there's an entire section just dedicated to Snap. It is the / button to toggle it on. So let's come over here. I'm going to hit that button on my keyboard, and now we'll see that it snaps very conveniently to the grid. If you don't like anything about how your grid is set up, you can always come back in here, set this to 1, or we could set this to a size of 2, or whatever really works for you. I'm going to go ahead and bring in a cube just as a sanity check to make sure things are okay. And that should be my 111 size. And now we can move around as you see here. So I'm going to fast forward through this and just move my pipes around until I make an interesting layout. Right now, these pipes don't have any kinds of a collider on them. If we select the pipe object itself, you'll see that we have a mesh filter and a mesh renderer, but we do not actually have any kind of a collider. If we go to add component, you could try simple colliders. For some objects like this pipe, a box collider is very simple and it might work okay. However, if we remove that and add something else like a mesh collider, this is where it's going to get a little bit nasty. Well, one, I'm going to turn isConvex on. This way it can actually interact with multiple rigid body objects. But more importantly, you'll notice that we've got this sort of space now. And if this was a high poly object, we could end up with a very high poly variation of this that slows down performance. What we can do is we'll go back to our 3D modeling artist here, and we could ask them, can you create a low poly version of this asset? And what they would do instead is they might take that base pipe, Control-C, Control-V to duplicate it, move this off to the side, and call this something like _C, maybe for underscore collision, or COL if C is being used as a convention for cages. And then they can come in, tab, and start removing the different elements that, well, are unnecessary for the physics simulation. These loops throughout this object really aren't required at all. Hit delete and dissolve those edges. Really, we can do this throughout the object, cleaning it up, making a much lower poly approximation. Why is this beneficial if it's not rendering? Well, it has to process the polygons in the physics engine. And these are great ways of creating low poly equivalents that are easier for it to work with. You may want to come in here and get rid of some of these edges that run along the sides, such as these ones here. They're probably superfluous for what we're doing. Or many times you'll want to go through and get rid of alternating bands. So this one, maybe this one. We'll leave those ones there. Maybe this one and this one. Right click, hit delete, and let's go ahead and dissolve those edges. Simpler, yes, but there's nothing saying that we can't come in here now and modify things, right? So if we go and hit shift space and we go to move, we can of course get this to look better. And at this point, now that we have it separated, there's nothing saying we can't bring it back to the origin. So let's undo that really fast. There we are. Get out of edit mode, come here, hit 0 on the keyboard here so we can see both of these together. And we can try to make this object larger than the one that it's enclosing, or smaller. It depends upon what you need. Come here, hit Alt, maybe deselect a few parts of this that we actually don't want. So in this case, let's just get rid of maybe some of these. And really, I don't need any of this. And then of course, let's move this object. And then now we can attempt to get this one to pretty much enclose most of the other object. And then you can do this for all the different sides. And then if you want to, we can go to File, Export, and then we'll do another FBX. And then we could call this pipe 2, and then _C, or whatever your convention may be. Hit Export, come back over to Unity now, and under pipe 2, right click, we'll go ahead and import a new asset. We will find pipe 2C, import that in. Now this is where it's super important that your transforms and everything were zeroed out and everything's in the same spot, because we're trying to unite this object and this object in the same space. If we now come over to that particular piece of pipe, like let's just say this one here, open it up, go to Add Components, Mesh Collider, you'll notice it says pipe _2. We select this and we choose pipe 2C. And now you'll see it's using the collider that we just created for this object instead. For complicated objects like this one here, you can follow the same convention, or as Unity says, you can always provide multiple colliders. There's nothing saying you can't create several box colliders on this object. Create maybe 2 here, and then we could resize this object and move it to the top piece here, shrink it down a bit. And this is where you can just take your time and try to play with making this correct. Adjust the Z value. If we liked those values for the general size, we could copy this component and we could paste values into this other one, and we can begin manipulating where this one's at. So here you can see we created a very strange and crude variation of this pipe using 2 boxes. Whatever works for you. The last thing I'll say is there's no reason you shouldn't be able to take huge assemblies like this one and then create prefabs out of them to use later in other levels. Then we have pipe bends with individual prefabs, but within this subcategory, we could create another folder called prefabs, and the idea behind this external folder is that it's going to be large assemblies of pipes. Go to game object, let's create an empty game object first, and call this pipe underscore waist to ceiling. Something like that. Grab all the elements that we want, move them into pipe waist to ceiling, and then do a quick sanity check on your pivots. Usually before you do that, you want to go in here and zero everything out or put it at a convenient place. So in this case, we can go in here, move all those, and then we're also going to want to do the same thing for these objects here, because now their origin is where this pivot was, here. So you may want to go through and offset everything by a certain amount. So come in here, move this somewhere maybe around here, and then take a look at where our pivot is, and that's close. Let's try this again. Move this over there. And now we have a pivot at a convenient location for the entire group. Grab this object, drag it into Prefabs, and let go. The more time you take to figure out your layouts, you can create more interesting ones that automatically connect with each other. And then hopefully now that you see this ability, there's nothing stopping you from coding your own connection system, right? So you could put empty game objects at the ends of each of these pipes, and those are your link points. Then you could go through and grab from a list of all of your pipes and then try to link them together, randomize the rotation if you wanted to make some sort of a crazy auto-generative pipe layout for your world. You could integrate collision detection, intersection detection, and make it so that the pipes lay out appropriately through your level. But that is obviously beyond the scope of this simple video today.